Okay, welcome to 4.5, the fifth lesson in the Chapter 4 series of video lessons here. Today we're going to talk about isosceles and equilateral triangles. You can see a pretty cool picture here on the right. I'm not sure what city this is. I'd guess Pittsburgh, but I really don't know. And we've got a good example of two congruent isosceles triangles here on a building. So any of you interested in architecture, here's some use of geometry in the real world. Okay, what we're going to do today is talk about isosceles and equilateral triangles and some properties of those that we can use to extend our knowledge once we know we have either one of those triangles. And then if you're wondering where 4.4 went, we're going to go back to 4.4 at the end of this and just kind of hit on it quickly, because it pretty much says the same things we said back in 4.1. So if you made 4.1, then 4.4 pretty much is just saying the same thing except with triangles here. All right, so let's just jump right in here. What we're going to do is start with a review of various triangle types here. Really three triangle types that are out there. We've got the scalene triangles, and a scalene triangle is simply a triangle where none of the sides and none of the angles are equal. Okay, generally speaking, when you draw a triangle, you've drawn a scalene triangle, unless you're trying to draw something different. Okay, then we've got the isosceles triangle. An isosceles triangle has two equal sides. Now it turns out that isosceles triangles also have two equal angles, and we're going to learn that during this lesson here. The hardest thing about isosceles triangles, of course, is remembering how to spell isosceles. So you might take a quick look at the spelling there, and notice that extra C right in the middle there that kind of stumps people most of the time. And finally, we have equilateral triangles. And an equilateral triangle is simply a triangle with three equal sides. So our scalene has no equal sides, our isosceles has two equal sides, and our equilateral has three equal sides. And another thing we're going to learn during our lesson today is that if we have an equilateral triangle, if all three sides are congruent, then it turns out that all three angles are going to be congruent as well. All right, so let's dive in here and start talking about isosceles triangles. Okay, before we go further, let's just talk about the parts of an isosceles triangle. The two congruent sides are what we call the legs of an isosceles triangle, and the angle that goes between the two legs is called the vertex angle. At the bottom of the isosceles triangle, we have the base. Now you don't have to draw your isosceles triangle with the base at the bottom. It can be upside down, it can be sideways, but generally speaking, we like to make our isosceles triangles like this, with the base at the bottom and our legs on the side. The two angles at the bottom that are at either end of the base are called the base angles. Okay? So two legs and a base, and a vertex angle, and two base angles. And what we're going to learn here in a moment is that the two base angles are in fact congruent to each other. Okay, and here comes our first theorem. So get your pen and paper out and go ahead and write this down. Just go ahead and stop the video while you write it, and then we'll talk about it. Okay. So isosceles triangle theorem. What it says is if two sides of a triangle are congruent, then the angles opposite those sides are congruent as well. So in this case, I've got myself an isosceles triangle, and all I need for an isosceles triangle is two congruent sides, and that's what I've got here. So if we look at the sides here, if I've got the left-hand side here, the angle opposite it is going to be this angle down here. And with this side right here, the angle opposite that side is going to be this angle down here. What this theorem tells me is if the two sides of the triangle are congruent, then the angles opposite are going to be congruent. So this angle right here and this angle right here are congruent. Okay? Pretty good stuff there. If I know my two sides are congruent, then I know my two angles are going to be congruent as well. Okay? And conversely, if I know the two angles of a triangle are congruent, then I know the opposite sides of the angle are going to be congruent. So if I know those two angles are congruent, then I know that these two sides are congruent. And that's called the converse of the isosceles triangle theorem. And if you want to write that one down, you just go ahead again, stop the tape, and write this down. Okay, now we're doing lots of proofs this unit, so I'm going to do another proof for you here. And this time what we're going to prove is the isosceles triangle theorem. And again, the isosceles triangle theorem simply said that if I have two congruent sides, then the two base angles are congruent, or the two angles opposite the sides, which are the base angles, are going to be congruent. So let's go through and do this. I'm given here two sides, AC and AB, that are congruent, and I'm asked to prove that angle C and angle B are congruent as well. Okay, so how do I attack this? Well, I'm not given a whole lot of information here. As you can see, I've got two sides are congruent, and that's it. I know nothing about the angles. Now, I wouldn't expect you guys to know how to prove this one. I happen to know from experience how to do it, so I'm going to jump right in here and show you that the first step right here is going to be to bisect angle A. I'm going to do that by putting a bisector in here. Okay, we'll put that line in there, and just to make it a line, we'll put a label at the end here, so we'll call it line segment AD. Okay, now what do I know about the two angles formed by that line, by that bisector AD? Well, by definition, because it's a bisector, I know that these two angles are congruent. Okay? So, what do I have now? Well, I now have an angle and I have a side. Still not quite enough to talk about anything in particular here, but what I can also say, and we're starting to realize here, is that the new side I just made here, this bisector AD, can be a common side to two triangles here. And as such, it's going to be congruent as well to itself. Okay? So what I've created here are two triangles, and I now know with these two triangles, I have two congruent sides and a congruent and an included angle. So with two congruent sides and an included congruent angle here, I know from the side angle side theorem that these two triangles are going to be congruent. Okay? And if they're congruent, then I know that angle C must be congruent to angle B because they're corresponding angles. Okay? Let's go through and do the formal proof on this. Let's start with writing down what we're given. That's how we always do our proof. So I know that AC is congruent to AB, and I know that because it's given. And I know that AD is congruent to AD. Why do I know that? That's reflexive property. Any line segment is congruent to itself. And now what else I know here is I know that angle CAD is going to be congruent to angle BAD. We'll box around this one here. And we know that because of the definition of an angular bisector. Okay, so what do I have now? Okay, well now I have two congruent sides and a congruent angle. I can use those three bits of information, bring those all three together, and that's enough to prove that triangle ACD is congruent to, okay, now here's where it gets tricky. We've got to make sure we name our other triangle correctly. Our corresponding part to A is going to be A. The corresponding angle to C is angle B. And the corresponding angle to D is, of course, going to be angle D again. All right, so I know all of this. I know these two triangles are congruent. How do I know that? Because of the side angle side theorem. Okay, and finally from that, I now know that angle C is congruent to angle B. And this is what I'm trying to prove here. How do I know that? Because corresponding parts of congruent triangles are congruent. Okay? And there we've proven the Isosceles triangle theorem. Again, what it said was if I have two congruent sides, then the angles opposite those two sides, the base angles, are going to be congruent. And we just proved that. Now, an interesting corollary off of this is I've drawn that bisector through A. Is that bisector also a perpendicular bisector of the line of the base of line CB? Let's clean things up a bit here. Is AD a perpendicular bisector? Well, let's look at it here. I've already proven that these two triangles are congruent, so therefore I know that this line segment and this line segment are congruent to each other. So therefore, we know it's a bisector of the line CB. Now we need to figure out, is it a perpendicular bisector? Well, this one's also pretty easy to look at. I've got these two angles right here, and I know because they're corresponding angles, they must be congruent. So I've got two angles that are congruent. They're also linear, so they must add up to 180 degrees. So these two angles must be right angles. So we also know now that it's a perpendicular bisector. So yes, that leads to the next theorem here, which says that if a line bisects the vertex of an isosceles triangle, then the line is also a perpendicular bisector. Again, stop the tape and go ahead and write this down. One more little quiver for your toolkit here. All right, pressing on. Okay, let's figure out how to draw an isosceles triangle. We're going to draw a few of these in the class, so we better know how to do this. And we can do it fairly easy. If you get your compass out and your straight edge, you can quickly draw an isosceles triangle. Something good to have at home, or even bring to class for when you're drawing these things. If you don't want to bring them into class, at least have one at home to do with your homework. So let's go ahead and draw an isosceles triangle, and we'll make it a 2-inch base, and we'll make the legs 3-inch. So how do we do this? You don't need to write down these instructions. I've just sort of put them up here. You can just follow along with what I do here with the straight edge and compass. So let's take my ruler here. And the first thing I'm going to do is I'm going to draw my base, and I said I want my base to be 2 inches, so I'll just go along my ruler 2 inches right to there. All right, that's pretty cool. All right, the next thing I want to do is I want to take my compass here, and I want to size my compass to 3 inches, because that's what I want my legs to be. So I'm going to stretch it out here to 3 inches. There we go, measured up to 3. I'm going to change the color here and make it red. All right. And then I'm just going to go ahead, and what I want to do now is put my tip of my compass at one end of the base, and it's there already. So let's just go ahead and rotate this up just a little bit, and then we'll make ourselves an arc up here. Okay, then I want to put my compass at the other end of the base, right there, like that. And we'll make another arc here. Okay. So now I've got an intersection of two arcs. You guys have seen this sort of stuff before. I'm going to take my straight edge and just bring it up here to the intersection there, right there. Draw myself a straight edge there. And I can bring it over here, swing it around again. And draw one more straight edge here. And voila, I have myself a nice isosceles triangle. And if I wanted to measure it, I put my ruler on there and see that the leg is in fact 3 inches long, exactly what I wanted. Okay, so fairly simple there to draw an isosceles triangle, just using a compass and a straight edge. Okay, let's jump into equilateral triangles for a moment, and then we'll do some workbook stuff. I know you're dying to get to the workbooks here. Okay, what do I know about an equilateral triangle? Like I said before, an equilateral triangle is a triangle with 4 congruent sides. Okay, I have a corollary to that. If a triangle is equilateral, then it's equiangular as well. What does that mean? It means if all the sides are congruent, then all the angles are going to be congruent as well. And a corollary to that is if a triangle is equiangular, in other words, if I know all the angles are congruent, then I know that all the sides are going to be congruent as well. So remember those angles? Yeah, don't worry about it. Never mind. We'll go there later. Okay. So one more construct here. We're going to go ahead and construct an equilateral triangle. These are a little bit harder to draw correctly than an isosceles. I mean, normally if you're not using it, but with a compass, they're just about as easy here. Let's just go ahead and draw. Let's just say we'll make it a 3" by 3" by 3" on a side equilateral triangle. So again, what I want to do here is I'm just going to take my ruler. I'm going to draw my base leg here. I'm going to make this 3 inches long. So there you go. I have a base, and I want all 3 sides to be 3 inches. Obviously, if this is going to be 3 inches and it's an equilateral triangle, then all the sides are going to be the same. So let's just go ahead and make that 3 inches right there. Okay. Let's change the color to red, and we'll make our side. And what we're going to do now is just make a little arc. And again, I'm going to bring it up a little bit. I don't need to make the full arc, but we'll make that much of it right there. And we'll bring it over to the other end of the base leg there. Put my tip right at the end of that. A little more perfect. There we go. And we'll make an arc here. Again, I've got a crossing point here. I take my straight edge, bring it up to where they cross, draw a line there, bring it down to the other end here, do the same thing. Draw one more straight edge here, and again, voila, we have an equilateral triangle with all 3 sides being 3 inches. So you can try that at home tonight if you want, just to see if you can do that. But 2 easy ways to draw isosceles and equilateral triangles. Okay, before we drop you off to do your homework here, or to do your workbook stuff, let's just take a look at a couple of problems and get you started. These are the first 4 problems on the worksheet. You go ahead and grab the worksheet and take a look at it. I've asked you guys to do the odd problems, and so what I'll do is, not to give away your work, I'll do number 2 for you here and just show you how to do it. What they're asking me to do is to complete each statement here and then explain why it's true. So let's take a look at number 2 here. Number 2 is asking me to tell me what other angle is congruent to angle BED. Well, let's come over to the diagram over here and find angle BED. It's right here, BED. Okay? And we can see that BED is part of a isosceles triangle that also includes the side BD, and therefore, because it's an isosceles triangle, and because I know these 2 sides, side BE and side BD, are congruent, then I know that the 2 angles BED and BDE are congruent as well. So BED is going to be congruent to angle BDE, which, if I did this in green, would be this angle right here. And why do I know that? I know that because of the isosceles triangle theorem. That's why I know that's true. Okay, so go through and knock out 2 and 3 on that one, and use kind of the same thing. Give me an explanation of why they are. Okay, then the next section is going to ask you to use a little bit of algebra. Okay, I've given you here's one of the examples, and what I'm given here is a triangle with an exterior angle, and asking you to find values for x and y. Well, if I look at this right now, what I know from my knowledge from chapter 3 is that this exterior angle right here is going to be equal to the sum of the 2 remote angles, x plus y. Well, that's not very helpful, is it? 135 equals x plus y. I don't know x and I don't know y, so that's really not going to help me a whole lot here. But what I do know here is I see the 2 little tick marks, which is telling me that I have an isosceles triangle here. And what do I know about an isosceles triangle? If a triangle has 2 congruent sides, then the 2 opposite angles are congruent. So this angle right here and this angle right here are congruent. So if I know the left angle there is equal to x, then the right angle must be equal to x as well. Okay, well, now we got a little bit more information here. And what else I know here is that these 2 angles here, the exterior angle and angle x, form a linear pair. So I know that x plus 135 must equal 180 degrees. So if I take 180 degrees and subtract 135, see what that gives me then. It gives me 10 minus 5 is 5, 7 minus 3 is 4. That leaves me with 45 degrees, so x must equal 45. Okay? And with x equaling 45, then I know this one right here is 45. This one right here is obviously 45. 45 plus 45 is 90 degrees. And I know all three of these angles add up to 180 degrees. So I'll take 180 degrees, subtract 90 degrees, which is the two x's, 45 plus 45, and that leaves me with 90 degrees, which is the value of y. Okay, doesn't look like it here, but that's supposed to be a right angle. So that's how you would solve that one. So you've got x and y. Okay, go ahead and stop the tape now and knock out the workbook. It's pages 111 and 112. Knock out numbers 1 through 23 odd, just the odd problems down to 23. If time is short, try to bias yourself to more to the backside, to the harder problems. Those are more what's going to be on the test. When you're done with those, you can go ahead and start the video again, continue the video on, and we'll take a quick look in section 4.4. Okay, that won't take very long at all. So just go do your problems, then start this again. Okay, I assume you finished the worksheet. So we're going to take a quick look at 4.4. And what 4.4 talks about is using those corresponding parts of congruent triangles. If you remember back in 4.1, I said that if two polygons were congruent, then I knew that all the corresponding parts of that polygon were going to be congruent as well. Well, we spent the better part of chapter 4 proving that triangles are congruent. We used our side, 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 our side, angle, side, our angle, angle, side, and one more that escapes me at this moment to prove that two triangles are congruent. Once I've done that, even though I've only had to show that three of the sides are congruent, or three of the components are congruent, once I know those two triangles are congruent, I now know that all six components of the triangle are congruent. All three angles are congruent, and the three sides, the corresponding sides of the corresponding angles, are going to be congruent. All right, a lot of words on the screen here, but that's pretty much what this says. And what I want you to take away from 4.4 is just go back and talk about the way we named our triangles and why it was important. When I'm told that triangle ABC is congruent to triangle DEF, I haven't drawn a picture for you here, but you can infer from this that angle A and angle D are congruent to each other because they're in corresponding positions in the name. Angle B is congruent to angle E, again corresponding positions, and angle C is congruent to angle F. Okay, get all that from the name. Similarly, I know that segment AB is congruent to segment DE. Segment BC is congruent to segment EF. And the one that's kind of hard to see is the one that wraps around the name. And that's segment CA. I don't know how we draw that. CA would be congruent to segment FD. And I've got that right there. We get all that from the name. And basically we know all six of those congruencies exist because the two triangles are congruent. That's really all that section 4.4 says. Naturally, we need to knock out one more proof here before we can call it quits. So let's do that real quick. I'm given two triangles here, okay? And in those triangles, they're adjacent triangles. They share a side. And I'm given two congruent angles, okay? I'm told that angle KBC is congruent to angle ACB, and angle K is congruent to angle A. And you can see those that are marked on the diagram to the right. So I have two congruent angles. Is that enough information to do anything here? Well, let's stop and decide what it is we're trying to do here. What are we trying to prove? We're trying to prove that side KB, which is this side right here, is congruent to side AC right here. Okay? Well, I can prove those two are congruent if they're corresponding sides, and I can prove that the triangles are congruent. So let's go through and do that. So I've got two angles here that I'm told are congruent. That's not really enough to show that these triangles are congruent. So what other information can I glean from this diagram? Well, they have a common side. Leg BC or CB is a common leg. So therefore, it's going to be congruent to itself. So I'll mark that with a congruent. And now what I have is I have a side and an angle and an angle. Or, said better, I have an angle, angle, and a side. Do I have a theorem that's an angle, angle, side theorem? I sure do. So I can prove, given angle, angle, side, that these two triangles are going to be congruent. And once I prove that the two triangles are congruent, then I know that the corresponding segments are congruent, and therefore segment KB is going to be congruent to segment AC. So let's go ahead and do this one. We'll do this one in a flow proof again. Okay, so let's write down, first thing we always do, the given. So KBC is congruent to angle ACB. Okay, it's a flow proof, so we'll put this in a little box, and we'll write the word given underneath it here. And the next thing we know is that angle K is congruent to angle A. Again, this is given. Okay, so those two given. The other thing we discovered in the picture there is line segment BC. And what I know about line segment BC, better leave myself enough room to write below it. I know that line segment BC is congruent to line segment BC. Why? The reflexive property. Using that reflexive property in this chapter, like we use the transitive property in previous ones, all over the place. Okay, so what I have now, I've got two sets of congruent angles and a not included side here. And all of that is enough for me to say that triangle, let's do this right, we'll call it triangle BKC is congruent to, now we have to be careful here how we name the other triangle because they got to be corresponding parts. The corresponding part to B is going to be C, the corresponding angle to K is going to be A, and the corresponding angle to C is going to be B. Okay, so I know these two triangles are congruent. Why do I know this? Because of the side, or excuse me, because of the angle, angle, side theorem. Okay, and finally, with that in mind, I can now say that line segment KB is congruent to line segment AC. And why do I know that? Because they're corresponding parts of congruent triangles are congruent. Okay, so I've proven those two are in fact congruent, and I probably should go ahead and mark them as congruent. There we go. All right, there we go. Okay, so let's just go ahead and finish up the lesson here. I want you to get out your workbook again. Look at page 105. This is just a standardized test. It's got about 7 questions. Just fill in the answers there. No hard stuff to do. Just answer those. Once you're done, about 10 minutes from the end of class, we'll wrap it up and we'll go back up to the classroom. So once you're done, please take your headsets. If they're the headsets you borrowed from me, just wrap the cord back around the headset, hand it back to me. Tear out your pages out of your worksheet, and we get back up to class. Put them in the turn-in box there, and be ready to wrap it up. Okay, that's it. You can go ahead and stop the video now.